alkaline and a weak base, acid and base equilibrium. As we have seen that not all the acid and base will reach to the equilibrium. Only weak acid and weak base will reach to the equilibrium, right? And since they are attaining the equilibrium, there are so many opportunities we have from those equations and so many solutions that we have from there. But and then pH as well. So I am guessing that you have had a try of these worked examples, and we'll move to that self-testing question very fast. So if you have any question, please stop me, otherwise I'll go fast, and then you can ask anytime. All right, I cannot see the chat box, so you have to use you have to unmute yourself and use it. Not this one. Okay, yeah. All right, so here we are. It says that question number 1. An aqueous solution has a pH of 10, right? First of all, let's refresh our memories a bit. That pH is negative log of is equal to negative log of hydrogen ion concentration, right? Hydrogen ion concentration or H3O plus, same thing. So, but for our simplicity, we just consider hydrogen ion plus concentration, pH. And then since pH is, this there is a hydrogen ion is here, we can also find if there is a pH something, let's say that X amount of pH. So what is the concentration of hydrogen ion? Well, we take the anti-log of it, right? So 10 power negative pH is equal to the hydrogen ion concentration. This is P. It's funny, but it's P is equal to hydrogen ion concentration. So this thing, I know that you know already, but just refresh if somebody has any confusion. And these two equations will be very important for us. We'll be needing this time to time. So in aqueous solution, it says that pH is 10 of the aqueous solution. Oh, another important thing is pH scale is 0 to 14, right? We all know that it's 0 to 14. So pH is 0 to 14. And then pH plus POH both together is actually 14. This is another equation that will be required. So is equal to pH 14. That is the maximum. So if we have pH is 10, obviously we have POH of 4, right? POH will be 4, obviously, because pH is 10. And since pH is the hydrogen ion concentration, negative log of hydrogen concentration, so we can get negative, this one, yeah. So 10 power negative 10, that is the hydrogen, anti-log of pH is the hydrogen ion concentration, and the anti-log of POH is the hydroxyl ion concentration, right? So this is, see my computer. So this is how we can find easily pH and POH. Given question number 2, given the following solution, solution 1, pH is 10, solution 2 is pH is 7, pH 5. So which of the list has the solution placed in order of increasing hydrogen ion concentration? Hydrogen ion concentration increasing. So in the solution, if the hydrogen ion concentration is increasing, okay, let's say that we know that it is a neutral solution is pH 7, right? pH 7 is a neutral solution, we know. So if pH 5, it is not a neutral, it is an acidic solution. If pH 5, it is not neutral anymore, acidic, acid. And if it is pH of 9 or 10, let's say, it is basic solution or alkaline. All right, so it is a neutral. It is neutral solution. Now, when you are going down the pH, the acidity is increasing. The stronger the acid, the lower the pH. The stronger the base, the higher the pH. So when we are going down, actually, the acidity is increasing. Acidity increasing means they have more hydrogen ion concentration. The strongest acid or stronger acid is that which can dissociate or can donate maximum amount of hydrogen ion. So that is the stronger acid. That's why. So when the pH is lower, the acid will have higher capability of donating hydrogen ion, and that is why in the solution there will be more hydrogen ion in the solution. So the increasing order, it will be in the increasing order. That means pH is increasing from 1 to 2, 2 to 3. So this is the answer for this. Question number 3 says that at 100 degrees centigrade, the ionic product of water, Kw, is this, right? At 100 degrees centigrade. Which of the following statements best describe pure water at 100 degree? Right? At 100 degree, which of the statements among these 4 statements, which one is best suited for this water at 100 degree? So since it is pH is Kw is 5.13 10 power negative 13th, right? From there, can we find the pH of the water from this Kw value is given? We can, because Kw is equal to the hydrogen ion concentration plus hydroxyl ion concentration, right? Hydroxyl ion concentration is equals to the multiplication of this concentration of both. So since they are in the solution in the water, the equal amount of hydrogen and hydroxyl will be there. So we can just take a squared value of this. It will be the same thing. And even to remove the square from the both side, what we do is we take a root over from both sides. So this is cancelled out, and there is no squared anymore here. It becomes messy here. It is squared. So what will happen is, if I want to remove the square, I just take the square root of this value, and square root of this value will give us what will be the value. Can anybody do and tell me what is the square value of this? Root over of this, the value of 5.13 times 10 power negative 13.
7.16 times 10 to the power minus 7.
1.1 times
7.
1.7.
No, 7.16.
7.16
to
times
the
negative 7.
Yeah.
Yeah. Okay, so if we take the negative log of this value, what will be the pH? Because this is the hydrogen ion concentration, right? This is the hydrogen ion concentration, right? Because it comes from here. We put the value here, this value, and then we took the root over, and then we got this value. So this is the or hydrogen ion concentration. And hydrogen ion concentration, if it is the hydrogen concentration, what is the pH of this? We take the negative log of this value. Negative log of this value. So what is the pH of this solution? Can anybody tell me?
6.14.
6.14. So it is the pH is 6.14. Good, thank you. So 6.14, just now I was telling that pH 7 is neutral, pH 5 or going down from 7 to 0 towards 0, it is acidic. Going upward towards 14 is basic. So what will happen for this? The water is acidic or basic?
Acidic.
All right. Because yeah, it is since it is going down from 7 towards 0, less than 7, so it is supposed to be acidic, but it is not the correct answer. At 100 degrees centigrade, water, as here I said, right, that it has equal amount of hydrogen and hydroxyl ion, and that is why I remove the hydroxyl and then I take the squared value. So does not matter water has the pH at this temperature of 6.14, but still it has the equal amount of hydrogen and hydroxyl ion. This is the one that I was talking right in the class during the lecture. You can recall it. So it has still equal amount, exact same amount of hydrogen and hydroxyl ion. So it is neither basic nor acidic. Is still, I mean, it is still the neutral ion, neutral solution. This is the new normal, you can say. It's the new neutral. At 100 degrees, 6.14 is equal to pH 7 at 25 degree. Okay, so it is the new neutral. Is that okay? Is that clear? Okay. Nobody talking, so I think it's okay. Question number 4 says that consider the self-ionization of water. All right, self-ionization of water. So this one, this is how actually water dissociate or ionize. Sorry, ionize. It is for simplicity we just say hydrogen plus. For simplicity, for it's easier to write than H3O plus, right? So water ionizes in this way, and it is more than 0. It's more than 0 means it's positive, right? Hydrogen ion, enthalpy is more than 0 means it is positive value. That means it is endothermic reaction. So heat favors the reaction to go forward. Which of the following statements about aqueous solution is true? All aqueous solution contains hydrogen and hydroxyl ion. Yes, it's true. Any neutral aqueous solution at any temperature will be same. Yes, it is true. Just now we have seen this. The water was, there is nothing else in the water, only water, and at 100 degree it becomes 6.14. At 0 degrees centigrade it will become 7 point something, 7.2 something, I forgot exactly, or 7.2. So it is not 7, or at 25 degrees, yeah, it is around 7. So it is not, I mean, whatever the pH, it will be always same amount of hydrogen and hydroxyl ion. The pH is increasing or decreasing because the hydrogen ion or hydronium ion, it will increase or decrease in the solution with the temperature, right? So in aqueous solution with pH greater than 7, that means pH more than 7, more hydroxyl ion is less than hydronium ion is less than hydroxyl ion. Yes. So when pH goes more than 7, it becomes basic or alkaline. Alkaline means more hydroxyl ion is there. So it is true as well. Question number 4 says, option number 4 says, a neutral aqueous solution at 100 degree has pH less than 7. Yeah, we have seen just now it is 6.14. Although it is a calculation, arbitrary value, but from the Kw value, if the Kw value is correct for this water at 100, so then it should have 6.14. If your water does not have 6.14 pH, that means the water probably is not pure. So all of them actually, A, B, C, 1, 2, 3, 4, all are correct. Question number 5 says an aqueous solution was prepared by pipetting 1 milliliter of 6 molar sulfuric acid into a 1 liter of volumetric flask and top up to the mark with ionized water. What is the pH of the solution? Any question anybody has? Brian says, can I ask if hydrogen ion increases with temperature? Why is the water neutral in question 3? Hydrogen ion is increasing, so is the hydroxyl ion, right? So water is dissociating like this. Water is dissociating, so we are saying that hydrogen ion is increasing, right? Water is dissociating in this way, and we are saying that hydrogen ion is increasing. If hydrogen ion increases, one water you break, you get hydrogen ion, and you also get hydroxyl ion, right? So you get hydrogen ion increasing, you break one water, you get one hydrogen ion, and then what happens to the hydroxyl ion? Just do they get expelled from the water, or do they just fly away? They're still there, right? They cannot go anywhere, they will be there. So if you make one hydrogen ion, hydroxyl ion is being produced as well. So that is there in the system, and that is why the hydroxyl ion is increasing. So if you break one, you get one hydrogen ion and hydroxyl. If you break two, in fact, and this way, you get one, right? There is no way that you can break only three. You have to break 2 or 4 or 6 or that way, right? So this is more precise or correct form of water ionization, but for simplicity, we say in that way that water is breaking or ionizing, and then hydrogen ion is produced, hydroxyl ion is produced. And that is why water is still neutral, right? Is that okay? Okay, so question number 5 says that an aqueous solution was prepared by pipetting 1 milliliter of a 6 molar sulfuric acid into a 1 liter of volumetric flask and top of the mark with the deionized water. That means it was filled up to 1 liter. Until 1 liter, the water was added. What is the pH of the solution? Now you see the sulfuric acid, H2SO4, when it dissociates, right? What happens is it is a strong acid, so it will dissociate, it will give 2 hydrogen ion and sulfate ion as well, 2 negative, right? So 2 hydrogen ion and sulfate ion. So what is happening here, that 1 mole of sulfuric acid is producing 2 moles of hydrogen ion. So 3 will produce 6 hydrogen ion. So double amount of hydrogen ion is being produced. All right. So now you see that 6 molar of sulfuric acid in 1 milliliter of 6 molar sulfuric acid. That means how many moles? It is in 1 liter. We are putting 1 milliliter. Let's say that, like yesterday in the lab, we take the out with the pipette and then we dissolve it in the another 1 liter beaker or 1 liter of volumetric flask. 6 molar sulfuric acid we took. So we have to, since we are dissolving in 1 liter, the concentration is being changed, but it is not a 6 molar anymore in 1 liter, but the number of moles are same, right? Number of moles does not get reduced. This is the particles inside. So 1 milliliter and 6 molar sulfuric acid means how many number of moles are there? How many number of moles are in 1 milliliter of 6 molar? Number of moles of sulfuric acid. So N equals C into V. C times V. Same equation. Concentration is 6 molar and volume is in liter. So this is 0.006. Right? This is 0.006. So 0.006 means in 1 liter means, sorry, it's not liter. So 0.006 moles in 1 liter, that means 0.006 molar of the solution. Now, new concentration in 1 liter becomes 0.006 molar. But sulfuric acid gives 2, right? 1 mole gives 2 moles of hydrogen ions. So 0.006 will give us 0.0 times 2, that is 0.012 molar of hydrogen ion. Hydrogen ion concentration will be 0.012. And the pH of the solution, we have to take the negative log of this value. And then it will give you the pH of the solution will be 1.19, 1.92. That is how you will get the pH of the solution. Question number 6 says that a solution of hydrochloric acid has a pH of 1 and 10 milliliter of the solution is mixed with 990 milliliter of water. The pH of the diluted solution is closest. What will be the new pH of the solution? We started the hydrochloric acid with the pH, right? That has a 1 pH 1. A solution of hydrochloric acid that we took and we measured the pH, it was 1. And 10 milliliter of that solution, and then we mixed it with 990 milliliter of the water. So altogether 990 plus 10, it becomes 1 liter altogether, right? 10, this 10, it comes here. So new solution volume becomes 1000 milliliter or 1 liter. 1000 milliliter or 1 liter, that is 1 liter. So it is not the same because I have diluted it. I have mixed it with 990 milliliter of water. So it's not the same. So it should be diluted. And then since it is diluted, will the pH be same? No, because pH depends on the concentration, not the number of moles, concentration of hydrogen ion. So new concentration, what is the new concentration we have to find out? First of all, what is the number? I mean, how do you find the concentration, new concentration? I know the volume is 1 liter. Now I just need to know the number of moles that is in this 1 liter. So number of moles, how do we find it? Well, there is the pH is 1 is given. pH is 1 given means, as I said at the beginning, that from pH, how do we find the hydrogen ion concentration is 10 power negative pH or anti-log. So this is the new pH. This is the moles, right? This is the number of moles of hydrogen ion, and it becomes 0. In 1 liter, so it becomes 0.1 molar solution. So it becomes 0.1 molar solution, right? Okay, 0.1 molar solution. Sure, you want to delete the comments or comment which one? Okay. So this is 0.1 molar. And then if it is 0.1 molar, negative log of 0.1 gives us, well, what? Log of 0.1 gives us 1. Right? What mistake did I make? here.
Sir, the
Yeah,
10 power of -1 should be
negative,
the
yes.
concentration, right?
Yes.
So I think we need to times the 10 millimeter first to get the mole, and then change, and then add with the 999 millimeter to
Yes,
get back
yes.
to the concentration.
Exactly. Thank you very much. So the pH we found, that is the hydrogen ion concentration from here, and then 10 milliliter of this solution. That means we need to find out the number of moles here. We found the concentration here, but the number of moles we have to find from this, calculation, and then only we can find the number of moles which we will be using in 1 liter of the solution. So concentration is hydrogen concentration 0.1. So I got the concentration, and then the volume is 0.1 times, this is the milliliter, so it will be V. So C times V. 10 milliliter means 10 over 1000, 0.01. 0.01, so it becomes times 0.1, 0.001, 001. All right, so negative log of 0.001 should be the answer for us. So negative log of this value, 0.001 is equals to 3, which is the answer for this. All right, so thank you. Question number 5, it says that 7, it says that 50 milliliter of 0.2 molar sulfuric acid, molar solution of sodium hydroxide is diluted to 2 liter with the distilled water at 25 degrees Celsius. What is the pH of the diluted solution? The Kw is given, all right? The Kw is given, and then we have to do is we have to find out the new, of course, the new concentration, because the 50 milliliter of 0.2 molar solution is being diluted 50 milliliter to 2 liters. So how many times this dilution happened, right? We have to find out the new concentration of hydroxyl ion. And for this, what we can do is we can find C1, V1, C2, V2 in this formula. From there, some know this formula in this way. Some of us know that N1, V1, N2, V2 both are the same thing actually. Same thing, N2, V2, right? So this is the formula. So from there, if we use the concentration of sodium hydroxide, right, of 0.2 molar concentration, and then 50 milliliter means 0.05, 0.05, yeah, 0.05 milliliter, and the C is we are looking for. So let me just write it. Concentration is 0.02, no, 0.2 times 50 milliliter means 0.05. And C2 is the new concentration we need to know, C2, and volume will be 2 liters. From there, we see that C2 or new concentration becomes 0.005, right? 0.005, and that is the hydroxyl ion concentration actually. 0.005, and that is the hydroxyl ion concentration for this. Since Kw is given here, from here we can find Kw is hydrogen ion concentration, hydroxyl ion concentration. We have seen this before. I don't need to write actually, but anyway. So from there, and the Kw value is given, C2 we have already found, that means this is the hydroxyl ion concentration. Why it is hydroxyl ion concentration? Why not hydrogen ion concentration? Can anybody tell me? Why it is hydroxyl ion concentration, not the hydrogen ion concentration we are considering? Because of sodium hydroxide. Sodium hydroxide is a strong base and it will dissociate fully. Okay, it is one single arrow, sodium hydroxide. What do you write? Sodium hydroxide. So sodium ion and hydroxyl ion it is producing, right? So that this is the hydroxyl ion, and that is why 0.005 is the hydroxyl ion concentration. And we rearrange this equation to get the hydrogen ion concentration, that is Kw over hydroxyl ion concentration. So in this way, we will find the hydrogen ion concentration. From there, I will get the pH of the solution by taking the negative log of it. Okay, and it will be 11.7, I think. Yes. Question number 8. It says, any question so far? Question number 8 says a solution of sodium hydroxide has a pH of 10 if the solution is diluted 100-fold. pH of the diluted solution is, what will be the pH of the diluted solution? It has a pH of 10. I am diluting it 100-fold. So will I get 10 over 100? What's the value? Yeah. 0.01? 0.1. Do I get the 0.1 pH? Or pH increases or decreases, or what happens? So first of all, I need to know what is, it's not that it's, simple that I can just divide this pH by 100 times. No, you cannot do that, because the pH scale is until 0 to 14. So we have to know, pH will be dependent on the concentration of hydrogen ion. So we have to know the hydrogen ion concentration in the solution. Solution of sodium hydroxide has a pH. So sodium hydroxide, so it will be more than 7. We understand that it is basic solution. So pH is pH 10. That means hydrogen ion concentration in the solution is 10 power negative 10. Right? This is the hydrogen ion concentration for the solution. Or okay, let's say that 10 power negative 10th. So what will be the hydroxyl ion concentration in the solution? Hydroxyl ion concentration in the solution, right? pH, 10 power 14 minus hydroxyl ion concentration in the solution. In the same way, we can find that it will be 10 power 14th minus 10. 14th minus 10, that is the hydroxyl ion concentration, which is sorry, there's a mistake here, yeah, which is negative 4th, 10 power negative 4th. It is the hydroxyl ion concentration this way, or from this way as well we can find it anywhere. After we have diluted it 100-fold, now it will be okay, because now we will be diluting. We already have found the hydroxyl ion concentration here. So we can dilute it now by this 100-fold or 100 times, or it says that the 100-fold that is saying, we can use to divide the concentration now. not the pH, the concentration we are we are getting. So we divided by 100 times, and then 10 power negative 4 is negative 4 over 100 by 100 is 10 power negative 1, 2, 3, 6. So it is 10 power negative 6. All right, 10 power negative 6. This is the hydroxyl ion concentration now in the solution. But the pH, the question is asking me the pH of the solution, not the pOH of the new solution. Right? We have the hydroxyl ion concentration. So we can find the pOH from here. pOH will be negative log of this value, 10 power negative 6, which is actually 6. pOH is 6, right? So what is the pH then? Because we know pH plus pOH is equal to 14 on the scale. So pH will be 10 minus 14 minus 6. So it is 8. It is 8. In this way we can find is 8. So when you are dissolving or diluting, this is the interesting thing is this was base or alkali, and then we dissolved it, and then it is getting reduced or getting towards 7, right? If I do the same thing for acid, it will go up. So when we dissolve or dilute it, when the base or alkali or acid gets diluted, it goes towards the neutral side. Okay.
Sorry,
Question number 9. Yeah.
Can you repeat question number 8 again?
Sorry.
Can you repeat question number 8? I didn't understand.
Okay. Brian, you says what so that means what hydroxide ion increases together with hydrogen when temperature increases? Yes. Yes, it's true for water. Brian, it's better if you you sent this message quite some time ago. I didn't see. That's why I'm saying that you just unmute and talk so that I can catch you in real time. Okay, for Munib, it says that to repeat this. Okay, for once again, let me delete this thing. The question is saying that I know that there is some pH of the solution, but I want to dilute it, and then I want to see, or I want to calculate what will be the new pH of that diluted solution. So first of all, what is the pH of the solution that we have, right? What is the pH of the solution that we have? The pH of the solution that we have is 10, right? pH of the solution is 10, and we have to dilute it. We cannot dilute the pH, the value of the pH. We only can dilute when we are adding water. We are not diluting the pH. pH is the reading. pH is the reading. We are diluting the concentration, whether it is hydroxyl ion or hydrogen ion in the water. We are just diluting this thing. All right. So let's say that this is a beaker, and this is a beaker, and I have a solution here, sodium hydroxide. Sodium hydroxide, which pH is 10. pH is 10 here in the solution. It was here until this level. I add until this level water. So what is happening? What is happening? The pH, should I write here actually? The pH was 10. pH was 10 in the solution. So the pH, you not diluting or you are not changing the pH. The pH is the effect of the cause that you do on the solution. All right. So now I had the sodium hydroxide here. I added some water. what will happen is sodium hydroxide was concentrated, it becomes diluted. Now, right? It becomes diluted. More water means it got the mole over water, the volume becomes increased, so it gets diluted. How much does it get diluted? So first of all, we need to know how much sodium hydroxide ion was there, right? So since it is sodium hydroxide, it should be a hydroxyl ion there, and pH is more than 7, so we understand this hydroxyl ion is there. So first of all, we need to find out what is the concentration of hydroxyl ion there. So how do we find the hydroxyl ion? Like 10 power negative 10th. That is the pH of the solution. Sorry, this is the hydrogen ion concentration of the solution, right? Negative anti-log of pH is the hydrogen ion concentration of the solution. So if I have the hydrogen ion concentration of the solution, I can also find the pH of the the pOH of the solution, because pOH and pH is equal to 14, right? So the same way we can find the hydroxyl ion concentration from there. So it is, if pH is 10, pOH should be 4, because altogether is 14. So pOH should be equal to 4, right? So hydroxyl ion concentration, from there we find it is 10 power negative 4th hydroxyl ion concentration, right? And we are now, we know that there is hydroxyl ion of 10 power negative 4th amount, and we are diluting to 100 times. Diluting means reducing, so we are dividing it by 100. If we dilute by 100, it becomes 10 power negative 6th, right? 10 power negative 4th, we dilute, 10 power negative 6 becomes. So since it becomes 10 power negative 6, it was 10 power negative 4th of hydroxyl ion here. Altogether becomes 10 power negative 6. So reduces. The concentration of the hydroxyl ion reduces. And from here we can find the pOH again for the new solution. For the new solution, the pOH will be 10 power negative log of 10 power negative 6th. Okay, so which is equal to 6. So since it is pOH, so we can find the pH from the equation. 14 minus 6 is equal to 8. All right, is it okay?
Yes.
All right. Okay, so question number 9, it says that 50 milliliter of 0.02 molar solution of barium hydroxide is added to 50 milliliter 0.6 molar solution of nitric acid. The hydrogen ion concentration of the resultant solution in moles per liter. Moles per liter does not ask us to do anything pH or anything, but if we can find the moles per liter, we can just use the calculator to find in 1 second. First of all, the resultant solution. Why the question asking is resultant solution? That means there is something left over. Is that, or it is a neutral? So first of all, we have to. What is the first thing that we should do for this type of question? Anybody?
Write down the reaction.
Exactly. We write down the reaction first. So barium hydroxide plus nitric acid, HNO3, right? And then it is producing barium nitrate, NO3 2, it will be, plus water. To balance the equation, I need to have 2 here and then 2 here, so it will be balanced. So now I see that 1:2 reaction, this one. Once again, recall that thing, right? I was talking too much, and I will be keep talking about this balancing the equation and number of moles. So 1 mole of barium hydroxide takes 2 moles of nitric acid and produces barium hydroxide and barium nitrate and sulfuric water. So first of all, how many moles of barium hydroxide do we have? 50 milliliter of 0.0 N equals C into V again, right? N equals C into V. From there, we will see that barium hydroxide that we have is, I don't know, need to calculate. Barium hydroxide is 50 milliliter, 0.05 times 0.02, 0.05 times 0.02 is equal to 0.001 number of moles. 1. What about nitric acid? 50 0.05 times 0.06, 0.003, 0.003. So from here we see that 1 mole takes 2 moles of nitric acid. So 0.001 will take 0.002. It's quite straightforward. So 0.002 it will take, and then I will be left over with 0.001. Right? 0.001 solution. That's correct. What is the wrong thing I'm doing? Times 0.02. 0.001, and then it is 50 times 0.06, 0.03, 2 reaction, and 0.001 mole will take 0.002. Which one at the end I will be left over with 0.001. The hydrogen ion concentration in the resultant solution in moles per liter. Oh, okay. So, is there anyone who can help me out? Is there?
Teacher, shouldn't there be only 0 left from BaOH, 0 moles left, because it will already be used for, with 0.02. Isn't that right?
Oh, yes. Why I am multiplying these two? Okay. No, it's correct, right? 1 mole of barium hydroxide takes out 2 moles, so 0.001 moles takes out 0.002 moles of nitric acid, and then at the end 0.001 moles of nitric acid is in the solution. Right? Munib, what I was meaning that number of moles we have to find from here for the BaOH2 means barium hydroxide. So number of moles we found that 0.001, right? And then for nitric acid, the same way, N equals C into V. So number of moles equal concentration and volume. The volume is 50 milliliter, means 0.05 liter. We have to convert it to liter, of course. We cannot just use the milliliter, times 0.06, right, molar. So from there we find it is becomes 0.003 moles of nitric acid. Now let's here delete it first. All right. So now you see that I have 0.001 moles of barium hydroxide and I have 0.003 moles of nitric acid, right? 1 mole of barium hydroxide takes out, barium hydroxide, which one is the limiting reactant? Which one is the limiting reactant? How do you find it? We divide by the coefficient. This is the coefficient. 1 for barium hydroxide by 1 and this is the 2. So we divide by 2 and then we find that it is still 0.001 and it is 0.0015. So still, since 0.0015 is higher than 0.001, so this is the limiting this is the limiting reactant. Limiting reactant will finish up faster, right? Limiting reactant will finish up faster and the excess reactant will be in the solution, isn't it? The excess reactant will be in the solution. Which one is the excess reactant? This is the excess reactant. How much of this will be there in the solution? Well, how much is being used up? For 2 moles of nitric acid will be used up. For 0.001, it will be times 2 will be used up. That means 0.002 will be used up. And if we deduct, 0.001 will be left in the solution. 0.001 will be left in the solution. Now, the thing is, it says that hydrogen ion concentration, okay, this is the number of moles. This is the number of moles we are doing so far. But the question is asking about the concentration. How much concentration we'll have? This is the number of moles. To find the concentration, I have to divide by the volume. What is the volume here? Is 50 milliliter and 50 milliliter. When I add it up together, becomes 100 milliliter. So divide by 0.1, right? Divided by 0.1, and that gives us 0.001 by 0.1, 0.01. So this is 0.01. This is the concentration, molar or moles per liter. Is that okay now? Anybody has question? Okay, question number 10. That if 50 milliliter of HCl of concentration of 0.3 mole per liter is added to 50 milliliter of sodium hydroxide of concentration 0.1 mole per liter, what will be the pH of the resultant solution or the final solution? Now, it's interesting thing is 50 milliliter plus 50 milliliter, both are added, and only the concentration of the different solution is different. For HCl, I have 0.3 mole per liter. For sodium hydroxide, I have a 0.1 mole per liter. Again, the same thing, N equals C into, we have to find the number of moles, and we have to find the limiting reactant. So limiting reactant will finish up faster, only the excess amount will be left in the solution, and that because of that excess amount, the pH of the solution become changed. So question number 9 and question number 10 is very similar to each other, same actually, only the different values. So by this way we can find out, and at the end we have to consider this 50 milliliter plus 50 milliliter to find the concentration of the hydrogen ion, and from there we find the pH of the solution. Question number 11, which of the following best describe a weak acid? All right, What is a weak acid? Weak acid does not dissociate completely. So it will have a ionization, low ionization or dissociation. It doesn't ionize low, high. And when it does not ionize or dissociate fully, what happens is the K value also does not get increased because the K depends on the multiplication of hydrogen ion times hydroxyl ion or positive ion and negative ion. So if the positive and negative ion is not much, right? So the Ka value will also not increase. So this is very small. Ka value is very small and percent ionization is also low. But if this question was asking the pKa value, if here is the pKa value, then it would be very large. The lower the Ka, the higher the pKa value. Is vice versa, inverse relation, pKa and Ka. Question number 12. It says that arrange the following three acids listed in decreasing order to order of acid strength from the strongest to the weakest. Okay, so for benzoic, strongest to weakest, which one more strong than less strong, and the weak. So K value for benzoic acid is 6.31. Chloroethanoic acid is 1.31 times negative third. So this is the lowest actually. And ethanoic acid is 10 power negative fifth, but this value is not that big. So it is a bit higher than benzoic. So chloroethanoic acid, of course, and then ethanoic, and then benzoic. This is the order. So chloroethanoic is the strongest, and then ethanoic acid, and then only benzoic acid. So benzoic acid is quite, weak. Question number 13. It says that which of the following is the acid with the highest pH? Highest pH. Which one will have the highest pH? Before we go, anybody has any idea or guess which one will? I know you have the answer, but why do you think that we will have? Let's say that it is C, or let's say it's A or B or C or D, whatever. Why will it have the higher Ka? Highest pH. The higher Ka means higher ionization or dissociation. The acid will be ionized highly, more, right? The higher the Ka. And that is why it will give more it will give us more of this hydrogen ion. And since hydrogen ion is higher, so that it will give us lowest pH. The more the hydrogen ion, the lower the pH. So the lowest the Ka is the weakest the acid and the highest the pH, right? So for this case, this is the highest pH means pH is going up more than 7, up. So I have to choose a weakest acid here. Among them, bicarbonate ion, 10 power negative 11th is the highest value. So it's the weakest acid. Question number 14, it says that the acidity constant of boric acid, H3BO3, which is a monoprotic acid, is 6 times 10 power negative 10th molar. And of hypochlorous acid is 3 times 10 power negative 8 molar. This means that if we compare solutions of these acids of concentration 0.1 mole per liter at the same temperature, the pH of boric acid will be higher since it is weaker. So which one is weakest acid? boric acid because 10 power negative 10, where is negative 8. Both are weak, but this is the weakest. Boric H3PO3 is the boric acid. And this is quite good in disinfectant, what we call disinfectant, right? To kill the germs, I think, yeah. So this boric acid is quite good. And then if you have ever used it during the carom, do you know the carom, the game? I don't know. With the need a sticker and your finger that you use on the board. So this is a good what do you call it? I forgot the term. That makes this something slide on it faster or easier. A powder that makes something to be less friction on it. Okay, anyway, I forgotten. Nobody is helping anyway. So acidity constant for boric acid is 10 power negative 10th. That means boric acid is very weak. And hypochlorous acid is 10 power 8. That means it is not that weak, but it's still weak. And it says that at the same temperature, if we compare, the pH of boric acid will be higher, right? Because it has less ionization, of course, so that it does not have that many of hydrogen ion because it's very low. So this is the correct answer. Question number 15 says that a function of a buffer in a natural system, such as blood, is the resist to change in pH. No, buffer does not take part in the salt concentration, reaction rate, or temperature, but it's the pH. It reduces the change or possibility to change in the pH range of the system. Okay, so is there any questions so far? Okay, Brian again asked a question. Sir, for question 8, can we use concentration of hydroxyl ion instead of hydroxide ion? The concentration of hydroxyl OH, hydrogen concentration, the concentration hydrogen ion instead of hydroxide. If you use the hydrogen concentration, then you find the hydrogen ion in pH, and then again from there you go to pH plus POH is equal to 14. So the same thing you can, yeah, you can do that, no problem. Maybe one step more you have to do. Okay, so just take maybe 2 to 3 minutes break, and then I'll be back soon. If you have any question, think about it, and then you can ask the question when I'm back. All right, I'm back already. So let's start and then finish faster. Question number 1, first exam question. I'm not going to do all those, but probably some of them. Red cabbage juice can be used as pH indicator. The chart shows below is red cabbage indicator chart, right? So when the color of the juice is red, that means we understand that the pH is from 1 to 2. If it is violet, then pH will be from 3 to 4 range. If purple, then around 5 till 7 or a little bit this way, that way. And that's the how we the red cabbage. So the red cabbage, it is, although it's it is not very red, right? We call it red cabbage, but it's purple color. So naturally, when we buy it, we find it around purple color. So the natural pH, near natural pH, that is 6, 7, around that time. But if we change, put it enough acid or base into it, the color of the juice will change accordingly with the pH. All right. So state what pH and color the red cabbage indicator would be in the following solution. 0.15 mole per liter solution of HCl. If we add 0.15 mole of HCl into that solution, what will happen is for that, and first of all, we need to know what will be the pH for that 0.015 mole per liter solution of HCl, so that we will know what will be the color in that pH range. So we need to know the pH of that the range for this HCl. So this is mole per liter already. We can just find the pH of this is negative log of this value 0.015, right? .015, sorry, something like that. So from here we see that it is 0.05 will be around 2, is it? Negative log of 0.02 is around 1.8. It is 1.8 something, so that it will become red, right? In that solution, in this solution, if I use in my test tube 0.015 mole per liter or molar of solution of HCl, and I put a red cabbage juice inside, so that it will turn red. If I have 0.035 mole of solution of potassium hydroxide, so the same thing, you have to find the potassium hydroxide, and it is a base, right? Strong base, so it is hydroxyl. So you have to find the POH from here. POH from here is negative log of this value 0.0335, right? So POH, and then only we will find the pH from here, that is 14 minus this, the pH that we will get. So this pH. And the pH we will get in this, it is around 12.2, right? So it is around 12.2. The pH will be 12.2, and it will be in yellowish color. For it, the juice will change the color yellowish. It says that question number 3 says that 0.5 milliliter of 0.015 mole of HCl and 15 milliliter of potassium hydroxide. So the same thing, we have to do the calculation, and first of all we need to write the equation HCl and potassium hydroxide. Potassium hydroxide, it is producing potassium chloride and water. All right, potassium chloride and water. So 25 milliliter of 0.015 mole of HCl means how many number of moles we have to find. The number of moles we will find for potassium hydroxide as well. And from that number of moles we will see from that number of moles we will see that which one is excess, because this is the 1:1 reaction. Right, it is 1:1 reaction. So whatever is excess, that will be in the solution. Let me quickly find out the number of moles. So for HCl, it is 3.75 times 10⁻⁻⁴, and for potassium hydroxide, it is 5.25. So it is 3.75 10⁻⁻⁴, and it is 5.75 10⁻⁻⁴. All right, so this is the number of moles, and from here we see this 1:1 reaction. So exact amount of potassium hydroxide will be used, and the leftover is 3.75, I think 3.75 and 5.25, in fact 5.25. So 3.75 will be deducted from here, and the balance is the potassium hydroxide, right? Whatever is the balance is potassium hydroxide. So from here, whatever the balance, because this is potassium hydroxide, is not HCl, so that much potassium hydroxide again is strong base, that much will be the hydroxyl ion here in the solution. Right, that will be the hydroxyl ion solution. Let's say it's X amount of hydroxyl ion, and that is equal to the concentration of hydroxyl ion in the resultant solution. All right, and from there we can find the pH, exactly what we have done before. Okay, we have done before. Any questions so far? Question number 2, it says that when 100 gram of ammonium chloride dissolved in 1 liter of water, an equilibrium mixture of mixture between ammonium ion, a weak acid, and water was established as follows. So ammonium chloride was dissolved. It says ammonium chloride. Yeah, 100 gram of ammonium chloride was dissolved in 1 liter. Right. So ammonium, this ammonium actually is from ammonium chloride, and we did not just write the chloride here. It should be okay for simplicity, just write chloride. And yeah, the chlorine is coming from here. Yeah, ammonium chloride. This is the ammonium chloride. NH4Cl is the ammonium chloride. So here is the ionic equation only shown here. That's why the chloride ion is not shown, because it is the spectator ion. It is on the both side. It is not doing anything. It's the same on the both side. That's why it is not doing anything. So ammonium chloride was dissolved, and then ammonia and hydroxyl ion, at some point the equilibrium is established. We have to write the Ka value, and Ka ammonia, I don't need to write it, you can write, because this will be the concentration of ammonia, concentration of hydronium ion, and concentration of ammonium ion. Water will be left over because this is liquid, right? It will be liquid, so it is left over for this case. Given the acidity constant of ammonium, right? This is ammonium, is 5.6 times 10⁻⁻10th at 25 degrees centigrade. Calculate the pH of the solution. If the acidity constant, that means Ka of ammonia, is 5.6. So the ammonia, if we want to write the acidity constant for ammonia, what will be the what do you call it, Given the acidity constant of ammonia is 5.6 times 10 power negative 10th, and when we calculate the pH of the solution, pH of the solution. So from there, pH means we have to find hydrogen ion concentration anyway, right? And acidity constant of ammonia is given when the ammonium ion is dissolved in the water. So it is producing this concentration. Let me write it here. So here actually we don't need to write twice, but anyway, NH3 times hydronium ion concentration, right? And then divided by ammonium ion concentration. And concentration. So this Ka value is given here. Ka value is given here, right? I have to find the pH of the solution. Can anybody give me a clue? How can I do that? Can anybody give me a clue? I mean, for the pH, I need the hydrogen ion concentration, right? I need this one. How can I find this thing? Looking at the equation, I see that ammonium chloride or ammonia is getting dissociated, and then ammonium chloride is getting dissociated, and then ammonia and water is being hydrogen ion is being produced. I have the Ka value. What I need is, I need this value, hydrogen ion concentration, I need. But one thing, that since they have achieved the equilibrium, that means in the equation or in the system, they have equal amount of ammonia and equal amount of hydrogen ion. So for this case, again, I can just take the squared value of hydronium ion, and then I can remove the ammonia from there. All right, ammonia from here, because it is the same amount it will be producing. So I have Ka, I want this, so I can find this, but what about the ammonium? How do I find the ammonium? Well, 100 gram of ammonium is dissolved in 1 liter. So ammonium chloride, it will be dissolved, it's a salt, so it will be the total, salt always get dissolved. Any salt, okay, will always get dissolved fully in the water. So since 100 gram of ammonium chloride, from there we can find the concentration or number of moles, right? 100 gram of ammonium chloride, the number of moles is divided by the molar mass, that is 53.444, 53.5 actually, 53.5. We divide 100 by 53.5, so we get 1.87. 1.87, actually this one. Ammonium chloride is 1.87 moles. In 100 gram, there are 1.87 moles. And this 1.87 in 1 liter already, I do not need to change anything, just this is the concentration. I already know this is the concentration. So I can use this 1.87 here. I can use 8.7 here, and then 5.6 times 10 power negative 10th is here. Right? So this is how I can find the hydrogen ion concentration, and then we get the pH. Once we get the hydrogen ion concentration, we get the pH from here. Any question? No. All right, so Eric wants us that for 1C, Yx is the concentration of hydroxide ion. This one? If it is this one, I did not do the calculation. I did not do the calculation. I just, put it X, any value that you will find. You have to do the math. You have to use the calculator to find out what will be the balance here. I just consider the balance is X. Okay, it can be anything. 5.25 minus 3.75. So it will be 1 point, I think, what is it? 5. Yeah, 1.5 is it? 5.25 minus 3.75. 1.5. So it is 1.5, right? The concentration is 1.5 times 10 negative. Don't forget this 10 negative fourth, of course. So 10 negative fourth. So this is the value I was considering it as. Okay, so no questions so far. Question number 3 says, is it the number of moles? Oh yeah, it's number of moles. Yeah, that's why I was saying that we have to consider this 25, 25. Yeah, 25 plus 15. So it is 50 milliliter. We have to consider that to find the concentration. So 1.5 times 10 negative fourth is the number of moles by 25 milliliter. So 0.025 in liter plus 0.015 liter together. So this will be the concentration, and then from here we can find the pH. Okay. All right. Question number 3 says that given pH of a 0.5 molar hypochlorous acid at 25 degrees centigrade is 3.91, right? 3.91. If it is 0.5 molar hypochlorous acid, does it sound like a bit contradictory that the pH is given and the concentration is also given? pH is this, right? This is the pH. 3.91 is the pH, and the concentration of hypochlorous acid is 0.5 molar. So why is so? Since we can find the concentration from pH, why it is so? Because hypochlorous acid is a weak acid, it does not dissociate fully. So even it is 0.5 molar, it is a small amount of it has been dissociated. And then how much it has been dissociated? Actually, we can find from this pH. So concentration of hydrogen ion we can find is 10 power negative the pH, that is 3.91. Right. So this is actually the concentration has been dissociated in the water. The rest is not dissociated. The rest is still in the water, but not dissociated, not ionized. So this is the hydronium ion concentration in the solution. Question number B says calculate the hydroxide ion of the solution in mole per liter given Kw is equals to this, right? Kw is given this one. So hydroxide ion concentration is quite easy. From there we know Kw is equals to hydrogen ion times hydroxyl ion concentration, right? So if we want to find the hydroxyl ion concentration, I just divide this Kw by this hydrogen ion concentration, that is 10 power negative 3.91. right? So this is, by this way we can find the Kw of the solution. Question number C says the right acidity constant expression Ka, calculate the value of acidity constant for hypochlorous acid at this temperature. So we have to find, I mean, we have found the hydroxyl ion, hydrogen ion, and Kw value we have. Acidity constant, again, the Ka is equal to the concentration of hypochlorous ion, hydronium ion, divided by HOCl, but not water, because water is liquid. So we will not consider that one. So that will be the equation for it. And then from there, we can find the Ka value as well, because we already have everything, like hypochlorous acid. Since we have found the hydrogen ion, hydronium ion, the hypochlorous acid, hypochlorite ion will be the same. If it is 10 power negative 391, if this is the value, this will be the same value for this, because same amount of hypochlorous ion and hydronium ion will be there in the solution. So it is squared. Only this thing we have to find. Let me write actually. So Ka is equal to hydronium ion times the hypochlorite ion, sorry, and then hypochlorous acid, HOCl. So we know that this one is equals to 10 power negative 3.91, right? We already know this one. And it will be the same thing as well, 10 power negative 9.31. We can find this one from the same thing. So what about this HOCl? Well, HOCl, it is a weak acid, and we consider it is 0.5, still 0.5. It does not dissociate, not much. How much? It's very small amount has been dissociated, so it's still almost intact. So from there we can find the Ka value. All right, so this is the same thing actually. Expression, right expression, and then the pH of this solution is this, calculate the same thing actually. So this is it for today. Do you have any question? And for this question number 5 is the same thing. You try it. If you have any question about it, you can just ask me anytime. Anyway. All right. Is there any question? Why for question 8, when I use hydrogen ion, I get a pH of 12. This one you're asking?
Yeah, so question 8.
But you get, have you tried this way? I don't know how you are trying, but you see that sodium hydroxide has a pH of 10, right? pH of 10, that means we have to know that what is the hydrogen ion concentration, and it is diluted 100-fold. So that number of moles of hydroxyl ion will be diluted. So first of all, let's know the hydroxyl ion concentration. All right. So pH 10 means POH. Although it is pH is saying, but since it is hydroxide, it is hydroxyl ion, because sodium hydroxide, there is no HCl there. So, or any acid there, so it is hydroxide. And that is why we have to find out how much is the hydroxide ion. And pH 10 means POH is 4, sorry. So from there we find the hydroxyl ion concentration is 10 power negative 4th, right? and then we divide it by 100. 100 is it says that 100-fold diluted. Okay. If I dilute 10 power negative 4 to 100, it will become 10 power negative. Still, it is the POH, or sorry, it is the hydroxyl ion concentration, right? So 10 power negative 6. This is the new pH because the solution was diluted. So the new pH will be there. The POH for this is 6. So the pH is 8. Can you share if you have any your screen you want to share? If you anyone else has any problem with this?
So that's me cannot use the hydrogen concentration, is it?
Hydrogen concentration. Yeah, you can use the hydrogen concentration as well. But you see that hydrogen ion is this, right?
Mm-hmm.
pH is 10. That means hydrogen ion concentration will be 10 power negative 10. 10 power negative 10. So from here, if we, so you want to divide 100 here? Is it the
Yeah.
way you are trying? No,
Yeah,
no,
that's
no, you
what I did.
cannot. No, you don't. You cannot do that because there is no hydrogen ion here. There is hydroxyl ion here, but it was converted to hydrogen ion. All this hydrogen ion or pH, these things are the calculation that we are doing. But in the solution, this is sodium hydroxide. Sodium hydroxide. So in the solution, actually there are sodium ion and hydroxyl ion. No hydrogen ion there. Right. So if you are trying to do that, it will be wrong because there is no hydrogen ion there.
Oh,
Okay.
okay.
So yeah, in this way, we can take help of this pH or hydrogen ion to get, hydroxyl ion concentration, to know about hydroxyl ion. Just you can use as a tool, and it is the vice versa. It is exact opposite. If the problem told me that it is not a sodium hydroxide, it is a HCl. Okay, it is a HCl, and the POH, let's say the problem says that POH is, let's say that it is, how can I say that, 8. POH is 8. It will be not like that anyway. But if it is like, if it asks me the same thing, I cannot use the hydroxyl ion. I can just convert, this thing to hydrogen ion. I have to convert it to hydrogen ion because in HCl there will be only hydrogen ion and chloride ion in the solution. Okay. Sodium hydroxide means sodium and hydroxyl ion. And since there is hydroxyl ion, when I am adding water, only this hydroxyl ion getting dissolved or diluted, not there is no hydrogen ion here. So hydrogen ion, nothing to do with that. If you are diluting by 100 times, it is totally different thing. You are diluting hydrogen ion, which is not there.
Oh, okay. I get it now, sir. Thank you.
We are telling you that at night, I'm telling you at night is, I don't know if it is a perfect example or not. At night, how much is the light is there, right? At night, in the darkness, I'm telling you that what would be the darkness for this? Because darkness, there is no measurement for this, only light. There is the absence of light, so we call it dark. So I don't know. I mean, maybe it's not a good idea or good example. So yep, that is the way. Anyone has any other question? If no, then I think we'll stop here. I'll see you on next Monday for week 10. All right, and All the best. Take care.